All right, so we're going to start working with triangles, still bisecting angles, bisecting sides, and what happens when we do that. So the first thing we have, so if something is, we have the perpendicular bisector theorem, which says if a point is on that perpendicular bisector, it is equidistant from the endpoints of the segment. So therefore, if CD here is a perpendicular bisector, that any point that I draw, if I was to draw a point here, 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 notice that I make an isosceles triangle from any of those points. So they're just saying that this point is equidistant from the endpoint. So in other words, this side and this side are congruent is what they're saying. So any triangle that you make or construct, you'll have those two sides congruent. And then of course the converse is just saying if you have two sides of a triangle that are equal in measure and E is on CD, or that E is on that line, then it makes it a perpendicular bisector. Okay? Any questions on the first two theorems? So if you have an isosceles, then it's basically saying if that vertex E with the converse, that vertex E is on that line, it becomes a perpendicular bisector. And on the 5.1, which is a perpendicular bisector, if you have it, then any point that is on that line tells you that those two sides are congruent. Okay? All right. So let's do some examples. So it says find BC. Now, I mean, the work is real simple, but it's again understanding the concept. What is the length of BC? 8.5. And the reason is I have a perpendicular line and our point C here is on that perpendicular line. Therefore, this side and this side are the same. Okay? Over here, we have the converse. What is xy? Xy is 6. And again, we have a right angle. And we have that this side and this side are congruent. Therefore, that makes WY a perpendicular bisector, which means that this side and this side are the same. All right. How do I find PQ? What do I do to solve? All right, so we have 3x plus 1 equals 5x minus 3. Again, we know that it's a perpendicular bisector so that these sides are congruent. And then we just solve, so we got minus 3x gives me 2x minus 3. I'm going to add 3. And I got x is 2. But it says find PQ. So I'm going to take that 2, plug it in, and get That PQ is 7. All right, any questions on this first part? All right, so our next theorem is circumcenter, okay? So what's happening here is if I take the perpendicular bisectors of each side, it's going to be equidistant from the vertices, okay? So just for a knowledge purposes, have you heard, like, if I said, given a triangle and I wanted you to draw a circle around the triangle so that it touches all the vertices, this is how you do. So if you ever, I don't know where else you would have it besides geometry, because I don't know about the levels above, but if you can actually, with a protractor and a compass, you can circumscribe, which is draw a circle around a triangle by doing this, by finding the perpendicular bisectors, finding that point that they meet, and then if you get your compass and put it on one of the vertices and just went around, it would go perfectly around this. Okay? So again, perpendicular bisectors of each side meet in the middle and, well, not middle, but they meet inside the triangle and they are equidistant from the vertices. So if I just did a black mark and I'll just do this, that means that this one here and this one here and this one here are all the same distance. Okay? That's what circumcenter means. And the way that I remember it is I circumscribe, which is go around the outside of the circle. Okay? Angle bisector theorem is similar to what we did above with our perpendicular bisector. So it says if a point is on the bisector of an angle, it is equidistant from the sides. Okay? So here again, if a point, which we would call as F, a point F here is on the bisector, then it's equidistant. Am I frozen? Or just log out. All right. So it's equidistant from the sides. Notice that whenever we talk distance, just the shortest distance between a point and a line is the perpendicular to that. So just remember that. And then the converse is saying that if a point is on the inside of a angle and it is equidistant, over here from the sides of the angle, then it is a bisector of the angle. All right. So let's look at this. Find DB. DB is what? 5. Okay. It's perpendicular, therefore it's going to be equidistant. Over here, find the measure of angle WYZ. That's going to be 28. Again, because your point is inside the angle and it's perpendicular, the angles are, or it's a bisector. And again, the last one, QS, we're going to solve by going 4x minus 1 equals 3x plus 2. We're going to solve. And again, it says find QS. So we're going to take that 3, plug it in. All right. Next one, find the measure of SR. It's a tough one. Notice it says my two angles are congruent, so it's a bisector. My distances, they're right angles. So SR is 11. And last one, again, same thing, set them equal to each other because I have the angles bisect each other. So I'll just do this, minus 3 plus 9 plus 9 minus 3. So we get 7 equals x. All right, any questions up to here? All right, last part to talk about. So this is the in center, okay? Yeah. Oh, it said find the measure of UV, thank you. So we take 3 times 7 minus 2, so 21 is 19 for UV. All right, the in center. So the in center is kind of that same thing that, or similar to the circumscribe. Circumscribe is a point that I can draw a circle around the outside, therefore it touches all the vertices. This one here is when I get my point in the middle, I can inscribe a circle. In other words, I could put a circle inside the triangle so it touches all three sides at just a point. So for this one, what you're doing is you're doing the angle bisectors of each vertex, and that point of intersection is going to be equidistant from the sides. So in other words, this and this and this are congruent if you do the angle bisectors of all three vertices. And again, if I put a compass right in that middle and I just drew it around the edges, it would go and touch all three sides. So inside. All right. Let's look here. It says if ST is, find ST if S is the in center. So if it's the in center, that means that this and this are congruent. this and this are congruent, and this one and this one are congruent. So that's the incenter. And if that's the incenter, then we know that the distance from here will go ST equals SU equals SR, if that's the incenter. Now notice it doesn't give us any of those, but it does give us UP and SP. And I don't think we've really talked about it, but what's the Pythagorean theorem? All right. What's the Pythagorean theorem? A squared plus B squared equals C squared. So the Pythagorean theorem is A squared plus B squared equals C squared. What must you have in order to have the Pythagorean theorem? A right triangle. And C squared is my hypotenuse. Hypotenuse. Okay. So if we're given the 8 and 10, I can just plug it in to find UF. So I would get, well, I'll just call it A squared instead of X squared. A squared plus 8 squared equals 10 squared. And if I subtract 64 from both sides, I get A squared equals 36. And A is going to be 6. Now, normally, if I took the square root, what would my answer be underneath? Not just 6, but positive and negative 6. And why am I leaving out negative 6? Can you have a negative 6 length? No. So therefore, all I'm doing is I'm just going to leave it as A equals 6. Okay? So with A equals 6, which is US, what is ST? All right, so ST equals 6 because it's the incenter. Okay? For the next example, or yes. Okay, so C is the hypotenuse. The hypotenuse is always opposite the right angle. Okay, and then the other two are kind of interchangeable. It doesn't matter if I put 8 squared plus B squared, you're just solving for it. So, but the important one is as long as it's a leg or, the sides that form the right angle, A and B are either or, and the hypotenuse is always opposite the right triangle. All right. Anyone else question? All right. So we have our diagram here. Again, it says S is the incenter. And it says find the measure of SPU. So we want this angle right here. Anyone want to venture thought? Yeah. SPR and SPU are the same, correct? Okay. And we also know what? RS, well, no. Okay, so therefore this angle right here is 28. Okay, if it's the in-center, it's the bisector. Okay, what else? Okay, so he's looking at this triangle right here. So therefore we take 90 plus 28 and 28 is 56 plus x equals 180. So the sum of all the angles is 180. So we get 146. So we're going to subtract 146. And we're going to get that x is 34 degrees, or the measure of angle SPU is 34. I'm gonna circle it in blue because it bisects. That's the same. Okay, so do you understand that my yellow is a triangle that I drew? Okay, so my circle of blue is one angle, right? The whole thing, the 28 and the 28 combined. And you know that the red 28 is there because it's the in-center, therefore it bisects the angle. Okay, so I have the 28, 28. I also have this right angle here of 90. And then what's left? My black, that little portion over there, which is the angle we're looking for. Yes, no? You sure? Okay. So I'm going to come off to the side-ish. NTP. You sure? Yes, STP. Yeah. Okay. All right. Let's look at my last example here. Find the measure of GF and of angle BCD if D is the in-center. Okay. So how can I find the measure of GF? We did this problem above. How can I find GF? Pythagorean theorem, okay? So I'm going to take the 5 squared plus the b squared, and again, it doesn't matter the order, equals 13 squared. So I'm going to subtract 25 from both sides. Just in case you don't know, that's 169. And I get b squared is 144. And when I take the square root, I'm only going to deal with the positive because we can't have a negative distance, so I get b is 12. Or GF is 12. Okay. How about BCD? So I have this angle right here, BCD. It's kind of the same thing that we just did. So I'm going to take, because it's an in-center, what else do I know? What angle? BAD is 35 if it's the in-center. And therefore, I'm going to take this triangle right here. And I know that if the right side is a 90 degree, the left side is going to be supplementary or a linear pair. So we're going to take the 90 plus the 70 plus, I'll call it angle BCD equals 180. And if I subtract the 160, I get my angle BCD, or the measure of that is 20. So the 160 is the 70 and the 90. All right. Now, I'm going to do this as a little extra. This is just good knowledge. So in the Pythagorean theorem, you have certain triples. You have what's called the 3, 4, 5 triangle. And then you have the 5, 12, 13 triangle, where 5 is your hypotenuse, 13 is your hypotenuse. If you memorize these, what you can do is double, triple, whatever, and then you automatically know what your Pythagorean triple is. In other words, these three. So if I multiply everything by 2 on the first one, notice that I get 6, 8, 10. That is a Pythagorean triple. If I multiply it by 3, I get 9, 12, 15. So on. I multiply it by 4, I get 12, 16, 20. So these are ways of knowing that, like, you can sort of just recognize that these are what they are. So if I gave you a 12, 16, let's say the last one, if you notice, if I divide it by 4, and again, this may make sense, it may not, but if I divide the 12 by 4 and the 16 by 4, I should know that this is a 3, 4, 5 triangle. And then if I multiply everything by 4, by 4, by 4, that this would become 20. If you get it, great. If you don't, not a big deal. You just have to do the algebra to figure it out. But I wanted to throw that out there.